Okay, students, today we are learning about Note 7.4, which is special right triangles. We are just continuing our study of right triangles and how they are very similar. So here we have an activity that we're going to do. For this activity, you're going to need graph paper. You're going to need a few colored pencils, a pencil, and some scissors. Okay, so here it says use graph paper to draw a perfect square. Cut out your square. That's the first steps that I'm going to do. So what I did is I'm going to number these here, my squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is going to be 10 units by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. And I'm going to cut out this square right here. So, cutting it out. Okay, I have a 10 unit by 10 unit square. And then don't toss your graph paper because you're going to need it again. But here I have, these are actually centimeters, so I have 10 centimeters by 10 centimeters. So I'm going to, on the back side, I'm going to label it. This is 10 centimeters. This is 10 centimeters. This is 10 centimeters. This is 10 centimeters. And then it said, okay, so I've drawn it, I've cut it out, and now fold it in half diagonally. So, do that, fold it in half diagonally. And you know you have a square when it matches perfectly. There's no leftover edges. It matches perfectly. Okay. And so here, when I draw this diagonal in, okay, better if you had a straight edge. Okay, then I have this right here, which creates two identical right triangles. And this side is equal to this side, because it's a square, so that means that these are two identical right isosceles triangles. Okay, so next it says measure the length of each side of, and this is a typo here, so if you'll fix it, measure the length of each side of the graph paper square. And when I measure it, I know that each side is 10 centimeters. So I'm going to put that on my diagram too. It's 10 centimeters, 10 centimeters, 10 centimeters, 10 centimeters. Okay. Then it says, use the Pythagorean theorem to find the length of that diagonal, the hypotenuse, of the right triangle you created. So here, this is there's a right triangle. So this is going to be 10 by 10, so we want to find this over here. So I know that a squared plus b squared equals c squared. So that's going to be 10 squared plus 10 squared equals c squared. That's 100 plus 100 equals c squared. That's going to be 200 equals c squared. So that's going to be the square root of 200 equals c. Okay, so this one is the square root of 200 is the hypotenuse. Now remember, we need to reduce this. To reduce this, that's going to be just 2 times 100. So that equals the square root of 2 times the square root of 100. And we know that this becomes 10. And we always write the whole number on the front side, so that's going to be 10 rad 2. Okay, so this over here is going to be 10 rad 2. Okay. Alright, so now take a look. This is 10 rad 2. Do you see a pattern here? This one's 10, this one's 10, this is 10 rad 2. So, without cutting out a new one that's 14 by 14 inches long, it says, what would the length of the diagonal be if the sides were 14? So if I change this to 14 and this 14, what would this be? Okay, if you guessed 14 rad 2, you would be right. And you can use Pythagorean theorem to find that out. That's going to be 14 squared plus 14 squared equals c squared. And then you would continue on to solve that, and you would end up getting c equals 14 rad 2. Okay, so that's how you would prove it. If anybody asked you to prove it, that's how you would prove it. Okay, here, what would the length of the diagonal be if the sides were 25 inches long? Well, following the pattern, the sides being 10, hypotenuse being 10 rad 2, sides being 14, diagonal being 14 rad 2, this would be 25 rad 2. Okay, so the diagonals of the square bisect the opposite angles, bisects these opposite angles, making congruent angles. So that one's congruent to that one, and that one's congruent to that one. Okay, that's another fact that you know. Okay, you're going to want to take tape, and you're going to want to tape it here because I will be looking for your graph paper as part of your notes, as part of your grade. Okay, so this is how it's going to look down here on your EOC formula chart, your star chart. They will have, it'll look just like this, formula for 45, 45, 90 right triangle. Okay, the reason why this is up here that says these are congruent, remember this was a 90-degree angle, and if both of these are the same, that means each one of these is 45, and this one is 45 degrees. That means this is 45 and that's 45. So this triangle right here becomes a 45, 45, 90. And whenever you have a 45, 45, 90 right triangle, we know that the legs are congruent and that the hypotenuse is going to be the leg times the square root of 2. This is another way that it's shown. X square root of 2. Okay. This is what it looks like on your formula chart, just like this. Okay, so now it says test the pattern on one of your triangles. So here, if you draw a square here and just give it a random number, let's say this is going to be 50 by 50, 50 units by 50 units, then what would the diagonal be? It would be 50 square roots of 2 units. Okay, so that's your test. Alright, next page. The next page deals with another special type of triangle called the 30, 60, 90 triangle. Here we want to start off with drawing an equilateral triangle. Remember, equilateral means that all of these sides are the same length. So you're going to take your graph paper, and it's easier if you have 3 sheets of paper that are all the same length to help you with this. So I chose to use sticky notes. If you have sticky notes, this might be helpful at home. If not, just cut out 3 equal pieces of paper. Colored paper works better so you can see it. So I'm going to use my sticky note and I'm going to line it up against the line, and I'm going to put 2 dots. So it's going to go from here to here. So this segment right here is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units long. Now, to create a triangle, it's kind of difficult. So I think it's going to be like there. And then I have to position them so that they will match. So if I touch this one, see how this one's left over? So I have to keep moving the papers around so that they form a triangle and they use the entire side of the piece of paper. So here, just Keep inching them together. Okay, so there's my equilateral triangle, and I'm going to use my straight edge to draw it. Okay, so here's the point up here, here's the point here. And then I'm going to cut it out. Okay, remove the paper. There's your triangle. Okay, so it says draw using a ruler and graph paper. I'm going to cut it out. And when you label your vertices, you're going to have to label them inside the triangle because you're going to cut the triangle out so you can do some folding, and you won't be able to see the ABC if you put it on the outside of the triangle because you'll cut it off. Alright, so there's mine. Okay. Now you can get rid of the excess graph paper. So here I'm going to label this A, B, C, and they're all the same size. Okay, and it says fold the triangle in half, matching angle C and angle A. So I want to fold it so that these are matching right here. Okay. So when you do that and you crease it, what it's doing is it's actually cutting the angle in half, making two congruent triangles. Two congruent right triangles. Okay, now notice what it did to the base. Because this side is congruent to this side, when you draw that altitude down to the base, this time is when it cuts it in half. Okay, so in our previous lesson we learned that when we draw an altitude down to the base, it doesn't always cut the base in half. But in this case, since this side is congruent to this side, it does. So this side is 1, 2, 3, 4, 5, 6. This is 6 centimeters. And remember, this one, this here, is the same length as this. Remember, this was 12. So this is going to be 12 centimeters. Okay. So here, and we want this point down here to be labeled D. Okay. Alright, so name the midpoint of AC point D. Alright, so here's some facts that we know about our triangle so far. Okay, so you know that the length of all three sides are the same. Okay, check. All these sides were the same. They're all 12. You know that the measure of each angle has to be 60 because since this is an equilateral triangle, it's also equal angular. So each angle is 60. You know that BDA and BDC, those are right angles, so their measures are 90. You know that the sum of the measures of all the angles is 180. You can find the above information, you can find using the information above, you can find the measures of these two angles here, DBA, DBA, and DBC. Well, if this is 60 degrees and this is 90 degrees, when you add those together and subtract from 180, you know that this is 30 degrees. And this will be 30 degrees. So that's a 30, 60, 90 triangle. Okay, so we know that that's called the altitude. We know it's a perpendicular bisector. And we know that we can use Pythagorean theorem to find the length of the altitude. So we can find the length of this using Pythagorean theorem. Okay, now find the measure of DBA. DBA, we just did. The measure of angle DBA is 30 degrees. And the measure of angle DBC is 30 degrees. Find BD. Okay, that's We want to use Pythagorean theorem. So that's going to be, we're going to focus in on this right triangle right here, and we're going to find this side of it right here. So that's going to be 6 squared plus b squared equals 12 squared. So that's going to be 36 plus b squared equals 144. I'm out of room, so I'm going to move it up here. I'm going to subtract 36 from both sides. That's going to be b squared equals, let's see, 144 minus 36 would be 108. And then square root of that, well, I'm going to go ahead and write it like this, is 108. So b is square root of 108. And remember, we can't leave it like that. So we have to reduce this. Now, here, I know that 108, when I add these digits up, that's equals 9. 1 plus 0 plus 8, that equals 9. So I know it's divisible by 3. So I'm going to take 108 and divide it by 3. That equals 36. And that's convenient because that means that the square root of 108 is equal to the square root of 36 times the square root of 3, or 6 rad 3. Okay, so that means that this over here is going to be 6 rad 3. Okay, so that shows you that we have a pattern. What is the relationship between the base and the hypotenuse? The base is 6, the hypotenuse is 12, so the small base is going to be double. The small side is double. Across from the 30 is the small side, the small leg, and so it'll be, if you double it, you'll get the hypotenuse. The long leg, you take the short side and you multiply it by the square root of 3. So here's what you're going to see on your formula chart, a 30, 60, 90 triangle. The pattern is going to be, this is the short side, x, that's the hypotenuse, so this was the short side, this was the hypotenuse, and this was the long side, long leg. Alright, this was taken straight off of the star chart, the taxi OC chart. Okay, so let's go ahead and test this. Let's pretend like we have a 10, 10, 10 units. Okay, so we draw the altitude straight down. It's going to cut this in half, so that'll be 5. And so this guy over here, we take the short side 5, that's going to be 5 rad 3. Okay, now you're going to want to take some tape, and you're going to want to tape it right here because I want to see that. That's part of your grade. Okay, the last page is our examples for practice. Okay, find the missing leg and the hypotenuse. So you'll write leg equals, these are matching, so you know leg is 8, hypotenuse. Okay, so remember, since these sides are the same, you know this is a 45, 45, 90 triangle. So that's going to be x, that's going to be x, and that's going to be x squared to 2. So you take the side, which is 8, and you multiply it by the square root of 2. Okay, the next one, the leg on this one is a letter. Okay, so that's variable d. So this is going to match this, so we know that that's going to be d units. The hypotenuse is going to be whatever this length is. Since this is a 45, 45, 90 triangle, then we know that the hypotenuse is going to be the side times the square root of 2. Remember, it's hypotenuse equals side times the square root of 2. Okay, that's the trick. Okay, so now what do we do whenever we're trying to find the legs. Well, here, this one's easy because that's side times the square root of 2. So the side must be 10. Okay, so what you do is you go backwards. So the hypotenuse, since we know hypotenuse is equal to side times the square root of 2, you're going to put 10 rad 2 equals the side times square root of 2. You're going to divide both sides by square root of 2. It's going to cancel out. And so that's going to be 10. The side is 10. Okay, so you can just look at it when it's like this and say that the legs, or the sides, equal 10 units. This one is a little bit harder because it doesn't have a radical here. Okay, so on this one, you're going to do the same thing. The hypotenuse, h, is going to equal side, I'm going to call it leg this time, leg times the square root of 2. So here, that's going to be 10 equals the leg times the square root of 2, divide by square root of 2, divide by square root of 2. So the leg equals 10 divided by the square root of 2. But remember, we are not allowed to leave a radical in the denominator. So the trick is to multiply it by rad 2 over rad 2. So that's going to be 10 rad 2 over 2, because rad 2 times rad 2 is rad 4, and rad 4 reduces to 2. And then you have to, excuse me, you're going to have to divide those two numbers, so it's going to be 5 rad 2. Okay, so the trick here, the shortcut, is to take the hypotenuse and divide it by 2, and then multiply it by rad 2. Okay, so that's the shortcut. So let's test it over here. If I take this and I cut it in half, I'm going to test the shortcut. So 10 rad 2, I'm going to divide it by 2. That's going to equal 5 rad 2. And then it says, then I'm going to multiply it by rad 2. So take this and multiply it by rad 2. Well, that's going to be 5 times rad 4, which is 5 times 2, which is 10. And see how it equals 10? So the shortcut again is to take the hypotenuse, whatever you're given, divide it in half, and multiply by rad 2. Okay, so all of these have been dealing with 45, 45, 90 triangles, so now let's practice the 30, 60, 90 triangles. Okay, 30, 60, 90. 30, that's going to be the short leg. This is the hypotenuse. This is the long leg. So that means this one's going to be the 1, or the x. This one's going to be multiplied by 2, the short leg times 2. And this is going to be square root of 3. I remember it as 1, 2, square root of 3. Okay, so here that means that whatever this side is, I need to double it to get the hypotenuse. So y is going to be 16. And then to find this side, the long leg, I take whatever this guy is here, 8, and I multiply it by the square root of 3. So that's how you do that one. Okay, again, this one over here, this is going to be the short. This is going to be the hypotenuse. This is going to be the long side. So you can say that this one is 1, or x. If you're going by the formula chart, they would call this x. They would call this 2x. And they would call this x rad 3. So that's what it looks like on your star chart. Okay, so here, and don't get the x confused, and that's why I don't do it this way. Don't get this x confused with this x. This is just saying that this is a side. This side is 11. So if you want to find the hypotenuse, you have to double the short side. So that's going to be 22. And if you want to find the long leg, you're going to take the short side and multiply it by rad 3. Okay, let's do one more. This is the short side. This is the long side. This is the hypotenuse. The short side is x. Short side, x. The medium side, or this side here, That's going to be the long side, long leg. And so that one is just going to be x rad 3. And then the hypotenuse is going to be x doubled, so that we write 2x. And we are done.